My name is Trevor and I'm a machine learning engineer at Datature. Today, I'm excited to present an overview of our new offering, Vi, an all-in-one platform for annotation, model training, and deployment of vision language models. Vision language models, or VLMs, build on the strengths of large language models by learning, reasoning, and generalizing through language. But what sets VLMs apart is their ability to understand not only human language, but visual information as well, including images and video. By incorporating visual inputs, VLMs can interpret and reason about the visual world. Whether the data includes images of animals, electronic components on silicon, or complex PDF documents, a VLM can learn to understand it and extract meaning from it. Importantly, VLMs fuse vision and language together. Visual concepts such as objects, layouts, and structures are learned alongside the language that describes them. This multimodal approach allows VLMs to reason across a much broader context than language alone. For example, when working with a PDF document, a traditional LLM would require the document text to be explicitly provided. A VLM, however, can visually analyze the document itself, identifying page layouts, characters, structure, and then use the language understanding to interpret the content, whether it's an academic paper or an insurance claim. Ultimately, incorporating visual information is essential to pushing foundational models to the next frontier of innovation. With that vision in mind, we designed Vi, and today we'd like to walk you through some of its key features. Specifically, we're going to cover dataset creation, data upload, data annotation, model workflow development and training, and model deployment. We know it's a lot to cover, so let's just jump right into the Vi platform. To begin using Vi, you'll first need to create a project. This can be done from your workspace home screen by clicking on the Create Project block. For this introduction, we'll be creating a phrase grounding dataset, but note that we also currently have VQA, or Visual Question Answering, and we are currently in the process of supporting dense captioning and freeform projects. Once your dataset type is selected, you can click Next. And then we'll be prompted to select our data type. Here, we'll click Image, and then we'll click Next. And now we'll need to configure a dataset with a dataset name, something like Vehicle Damage Dataset, and we'll set a dataset description as well. We can select a dataset localization, and then once we're ready, we can click Next. Now we'll be given an overview of our dataset along with a summary of our choices, and once we're ready, we can click Create Dataset to begin. Once created, we'll be brought to the Overview page. Here, as soon as we have data annotated, we can visualize high-level statistics about our dataset. But for now, it's blank. To start annotating data, we must first upload images. To do so, click on the Explorer on the left side of the page. From here, we can navigate to the Upload Assets tab and begin uploading by either dragging and dropping files or clicking and selecting the files we'd like to upload. Once selected, we'll start preparing the files for upload. When you're ready, you can click Upload Files and we'll process those in the background. When they're done processing, we'll give you a notification in the top right corner to let you know when they've processed. Since processing is finalized, we've received a notification via the notification bell in the top right. We can then navigate to the Manage Dataset tab and view the assets we've uploaded there. Now that we've uploaded an asset, we can begin annotation. On Vi, data annotation can take many forms, with different formats depending on the downstream task. For example, phrase grounding involves annotating an image, providing a caption, and grounding phrases within that caption to image annotations. VQA, however, does not involve annotating an image, but requires a set of question-answer pairs for each image. There are two main ways to add annotations to your project: by creating them yourself via our on-platform annotator, or by importing them via the Import Annotations feature in the Explorer page. First, we'll cover creating your own annotations. To do so, click on Annotator on the left side of the page. Once loaded, you'll see the annotator, which features three windows: the image annotator on the left, the phrase grounding text editor on the right, and an asset library down below. First, click on an asset and you'll see the image annotator and text editor update with the asset and a line of text respectively. Additionally, a tool hotbar will appear above the gallery. Second, we must provide a caption, which we can do in a couple of ways. The first of which is to type our own. We must first click T, or the text tool, on the hotbar. This will allow us to edit the text inside the text editor. Then we can begin typing our caption, something like, "There is a dent on the back right bumper of a light-colored car." There also seems to be smudge marks beneath the dent. Now that we have our caption, we must create phrases to ground the image annotations, which can be done by either creating your phrases first or creating image annotations. We'll do so by creating our phrases first. To create our phrases, once outside the text edit tool, you can click H to hide a phrase or select the highlight tool from the hotbar. Once selected, we can highlight text as usual, but when releasing, you'll see that your text has been highlighted and you're automatically transitioned to the rectangle tool to ground the highlighted phrase. With the rectangle tool, you can now click and drag to create an annotation that is relevant to your highlighted phrase. Once finished with grounding the previous phrase, you can now highlight another phrase in our text, again by clicking H, highlighting our text, such as smudge marks beneath the dent, and ground it to another area on our image. Now we will showcase using IntelliScribe to automatically generate captions for your dataset. Note that to speed things up a bit, I've added a few more images to our dataset with relevant annotations. To activate IntelliScribe, we press C, or may select the respective tool in the hotbar. Note that by default, IntelliScribe will use the previous annotation context to automatically inform our caption. We can see the generated IntelliScribe caption below. Damage to this car in the form of a dent at the left of the rear bumper. We can press Tab to accept, then change anything the way we want to here. For example, this isn't the left of the rear bumper, but it is the right of the rear bumper. Now we can add our phrases and groundings just as we did before. The second way to provide annotations to your dataset is going to be by uploading your own annotations. To do so, head on over to the Dataset Explorer page, in which you can go ahead and click the Upload/Export Annotations tab. Here, you'll see an option to upload your own annotations. To do so, you have to select an upload format. What we'll choose is VJSON-L for now. For each format, there will be a format review down below so you know how to format your files. Click Next, and now you'll be prompted to upload a file. Here, we'll upload dump.jsonl and then click Submit when ready to upload. We'll process those in the background for you, and you'll receive a notification when the uploads are done processing. Now that we've received a notification that the uploads have done processing, we can go ahead and head back on over to the Overview tab to see that there are annotated assets now. Before it was 0, now there's 9. And if we head over to the annotator, we can click on any of the assets in the gallery and see that they've been annotated. For example, damage to this car, where it's grounded, dents and scratches at the right front door is also grounded. Once we've finished adding the initial annotations to our dataset, we can create a training project. From the Overview dashboard, you can navigate to the training project flow by clicking the Training button in the bottom left corner. Similar to our dataset, we want to create a phrase grounding project and follow a similar setup configuration as our dataset. To do so, we can click the Create Training Project block, select Phrase Grounding, click Next, add a project name, a project description, and select the localization. Once finished, we're presented with a project summary. We can confirm the following and then go ahead and click Create Project. Now, we should be brought to a blank project overview page. To start, we want to create a model workflow, which you can do so by clicking Create Workflow located in the top right. This brings us to the Workflow Editor page with a few different pieces. First, we have the System Prompt block, which allows users to customize their model's system prompt. For a project task, we do provide a default system prompt that we've optimized for the downstream task, but if users would like outputs in different format, different constraints, or anything else, they can specify it here. We then select a dataset, in which we'll select the dataset that we've just annotated. Now, let's select the model. Hover over the plus connected to the dataset block. Here, you can see a number of models that we have available. Let's go ahead and select Qwen 2.5 VL. Once selected, we're presented with a bunch of model options, such as model size, training mode, and quantization. Compute parameters like precision type and hyperparameters such as epochs, learning rate, batch size, and more. We also have evaluation options you can choose, such as max new tokens, top K results, top P, and more. Once you've selected your choices, you can go ahead and click out of this and then click Run Training. We'll then present you with some advanced settings, with options in checkpoint strategy and advanced evaluation. Once we click Next, you'll be able to set up your hardware configuration, deciding whether to run the training in our vCloud or on your own infrastructure using a custom runner. If running on vCloud, we have a number of GPUs you can use, as well as a multiplier of multiple GPUs that you can use to run in the training. We can then click Next and we'll see some data sanity checks to ensure that your dataset is ready for training. And then once you've confirmed the summary, you can go ahead and click Run Training. Then we'll be brought to the Run screen, and we'll see that the training we just set up is currently initializing, but we can check back later to see your model training in progress. Checking back, we can see our model training, which allows us to see a few training and evaluation metrics, namely total loss and more than a few evaluation metrics. In the case of phrase grounding, we have evaluation metrics to understand how our model performs not only with phrase generation, but also bounding box generation. So metrics such as BLEU score, BERT score, Meteor and Rogue, but also BBox IOU, Precision, and F1 score are all available. We can also view how our model performs on example images and visualize how it's progressing with advanced evaluation, which gives us samples of model inference on an unseen subset of your dataset. Moreover, we have raw training logs in case you may need those. Cutting to a different but finished model training, we can see that our loss charts and evaluation metrics have filled out. Moreover, if we head on over to advanced evaluation, we'll see that we have a final prediction in our trained model for each of the evaluation specimens that we provided before. To deploy a model, we can navigate over to the Models tab on the left side of the screen. Once clicked, we'll see all of our model artifacts. We can then click 3 dots in the bottom right corner of any of our artifacts to export the model. Here, we can click the Export Model button and an Export Model pop-up will appear. We can click Generate to present a script that will allow us to run inference using our model via Datature's Python V SDK. Let's see how we can leverage it to run inference on an unseen image. Now here we provide the inference script with our secret key, organization ID, and run ID, successfully loading the model, and we're going to process it on this image here, which as you can see, it is going to be an image of a car with some damage to the front left, as well as the wheel right there. If we go back to our script, we can go ahead and run the model just by clicking on the model forward. And once that happens, you can see that we have these current model outputs in which we're giving a phrase grounding response. These are going to have, the sentences and the particular grounded phrases automatically included, as you can see here. And then once we can go over, we can actually display this once we have a response back from our model, in which it's going to take a second to load, but you can see that we have damage to a black car with a broken front bumper and a damaged wheel. And once it's done processing, you'll see that the groundings are applied with the phrases to show a black car with a broken front bumper and a damaged wheel. And again, you can go back up to this, see the groundings for those provided, as well as the associated phrases. And if you need it, they're output. In this video, we've seen how to use Datature's V platform to fine-tune custom VLMs on your data. In the coming weeks and months, we are looking to support other core features, such as freeform project types, video support, more models, local inference, and more. Moreover, a slew of advanced features are being worked on as well, such as speculative decoding, RAG integrations, and more. Thank you again, and please stay tuned to learn more about V in the future and videos and releases. Thank you.